Hi, welcome back to the 6.1 Intro to Stoichiometry notes. In this video, we are going to go over some examples. So at this point, you should have all the key information that you need to help you with solving these example problems. Okay, so we're going to follow these steps to solve these problems. The first one is a compositional stoichiometry. We're not going to spend too long on these problems, but I do want to show you what they look like. The bulk of this unit, we're going to deal with reaction stoichiometry. So in this problem, it says, how many hydrogen atoms are there in 5 grams of H2O? So our first thing we're going to do is we're going to read the problem like I just did and identify our given and find. So I'm given 5 grams of water. I know I'm given 5 grams because I'm of water because that's the one I have the value for. And it says how many hydrogen atoms, that's what I'm asked to find. So now what I want to do is I want to map out my plan. Remember that your map will look something like this. Where you start and where you end depends on what the amounts of your given and find. So in this case, I'm given 5 grams of H2O. So step 1 says if the given is not in moles, we have to use the mole map equation to convert to moles. Okay? So since this is given to me in grams, not moles of H2O, my first step is to convert from grams of H2O to moles of H2O. All right, so that's step 1. Now my next step is to convert from moles of given to moles of find. So now I'm going to go from moles of H2O to moles of hydrogen. The substance I'm asked to find is hydrogen. That's not the same as H2O. Even though they're hydrogen atoms in water, they're not the same exact substances. They would have to have the same exact chemical formula. So now I want to know how many moles of hydrogen. Now the last step is if you're asked to report the find in something other than moles, then you're going to use the mole map once again to convert from your moles of find to the amount of find. In this case, I'm looking for the number of hydrogen atoms. That's not the same as moles. So I have to do 1 mole conversion from moles of hydrogen atom to number of hydrogen atoms. Remember the difference between a mole and the number of things is that a mole is more like a dozen. Like if I had 48 donuts, I would say I had 4 dozen donuts. So that 4 would be like a mole. And then the number of hydrogen atoms is more like the actual number of donuts. If I counted all the donuts, that would be like the 48. So these are not the same exact things. They are equivalent, but that doesn't mean that they're equal. Equivalent meaning that they are related through that Avogadro relationship. All right, now that we have our map done, let's go ahead and get started with the solving. So the first thing I want to do is I want to do step 1, converting from grams of H2O to moles of H2O. So this is the part of the stoichiometry problem where I need to go to my mole map. So what equation am I going to use? If I want to convert from grams, which is mass, to moles, I'm going to use this equation. Mole equals mass over molar mass. All right, so let's go ahead and set it up. I'm trying to solve for moles. I'm trying to get to the moles of H2O. So I'm going to go ahead and write that down, moles of H2O. And I know that that's going to equal my mass of H2O, which is 5 grams, so 5 grams, over the molar mass of H2O. Now remember, to get the molar mass, you use the periodic table and add up the average atomic masses for hydrogen and water. So I'm going to do that work up here on the side. So for H2O, the molar mass of H2O is going to equal 2 times 1.01, because that's the average atomic mass of hydrogen. I have 2 of them, plus 16 for the oxygen. I only have 1 of those. So that's going to be 18.02 grams per mole. And that goes under here. So first I'm going to do is convert the moles of H2O so the mass of H2O to the moles of H2O. So 5 grams to the moles of H2O using this equation down here. Okay, great. So I go ahead and I plug that in. I divide 5 by 18.02. And that gives me 0.277 moles of H2O. So right now in my plan, I'm here. I have my moles of H2O. What's next? The next thing I want to do is now for step 2 is convert from moles of H2O to moles of H. So moles of what I'm given to moles of what I'm asked to find. So I'm going to do step 2 down here. And this is where I'm going to use dimensional analysis. So remember with dimensional analysis, you're going to take what you're given, and right now I'm since I'm here, I'm going to start with the moles of H2O. So 0.277 moles of H2O. And you're going to put it over 1 just to make it a fraction. Now the second fraction is going to come from the conversion factor. My conversion factor here is my mole ratio. So in order to figure out the mole ratio, we need to look at the substances we're comparing, H2O to hydrogen. And we know that there are 2 moles of hydrogen for every mole of H2O. So the mole ratio here is 1 mole of H2O is equal to 2 moles of hydrogen, like what we wrote up here. The question is, what part goes in the numerator, what part goes in the denominator? Since I want to cancel out moles of H2O, and I want to keep moles of H, I'm going to put the moles of H2O in the denominator here. So the moles of H2O is going to go in the denominator here so they can cancel out. And that would be 1 mole of H2O. So this whole thing goes in the denominator. And in the numerator, I'm going to take the 2 moles of H atoms and put them up here, because this is basically a 2 to 1 mole ratio. Now, of course, I can do my math. So remember, idea is these units cancel out. And my math looks like this. I'm going to take 0.277 times 2, and that will give me the moles of hydrogen atoms. And when I do that math, I get approximately 0.555 moles of hydrogen. All right, that's step 2 done. Now we're on to step 3. For step 3, I need to convert, I'm asked to find the number of hydrogen atoms, so I need to convert from my moles of hydrogen to number of hydrogen atoms. So I'm going to do step 3 up here. Okay, so for that, we're going to use Avogadro's number. So I'm starting with 0.55 moles of hydrogen. And again, I'm going to use dimensional analysis here for Avogadro's number. You can also use proportions, but I'm going to use dimensional analysis. And I know that for that, the conversion factor comes from this, right? If I'm going to convert from moles to number of atoms or molecules, I use this conversion factor. 1 mole is equal to Avogadro's number, 6.02 times 10 to the 23 atoms or molecules. So the part of this equation that goes, conversion factor that goes in the denominator will be the 1 mole, since I want to cancel out moles. And then Avogadro's number goes on top. Okay, so what I'm going to do here, I can go ahead and cancel out moles. And my math looks like this, 0.55 times Avogadro's number. And when I do that, I get this value, 3.34 times 10 to the 23 hydrogen atoms. Okay, so that's how we do that compositional stoichiometry. All right, we'll look in the next video, we'll look at reaction stoichiometry, mole to mole, and then mass to mass.